Welcome back to this next part of functions. I refer you to 4.7.4 of your notes. We are talking about the graphs of F inverse F and FF inverse. Basically, these two graphs, these two functions are also composite functions, but these are special composite functions that we want to highlight. Let us consider a function called just a simple 2x plus 1. Right? 2x plus 1. Basically, you have f like that. It processes number like that. You put in, say for example, 0, you will get a 1. That means f0 is a 1. Let us use another number, say 2. You substitute in, you get a 5. 3, you substitute in, you get a 7. That means f2 is a 5, f3 is a 7. Right? Now, what is f inverse f0? Let me put it this way. What is this? This the other way, the process number, the inverse function is such that it goes the other way, am I right? So, can I then say what is f inverse f0? f0 is 1. So what is f inverse 1? F inverse 1, if you look here, is actually back to 0. Similarly for this, what is f inverse f2? Is actually f inverse 2. Sorry, I beg your pardon, f inverse 5. Why? Because f2 is actually 5 here. What is f inverse 5? You go the other way, you get back 2, of course. Now I think you get it, that actually you will get back the same thing. Now, does it make sense then f inverse f a will always get back a? Of course. Actually, does it matter whether fx is 2x plus 1 or 3x plus 1 or 10x plus 1 or x squared plus 8? Actually, it didn't matter. Because by the sheer definition of f inverse like that, actually f inverse f, whatever it is it x, you will always get back x. Does it work the other, what about this one? F inverse x. I think you know. Let us use an example. What is f inverse 1? Look here, it's actually sorry, maybe I don't write here. What is f inverse 1? What is f inverse 1? F inverse 1, here, f inverse 1 is actually 0, which is f0. And what is f0? f0 you get back 1, of course. You will get back the same thing. You do the same thing for the few numbers, you realize that this one will also be x. So, I think I want to highlight this result. No matter what. Which means, actually the composite function, regardless whether it's 2x plus 1, 3x plus 1, does it matter? It doesn't matter. I then also want to recall, what is the domain of a composite function fg? Because f inverse here is just a special composite function. It's essentially a composite function. So domain of fg is actually the domain of g. You look at the previous set. You look at where we first introduced composite function. What is the domain of a composite function, which is actually 4.7.2. Right? So it is actually domain of G. So therefore, domain of F inverse is actually the domain of F inverse. Similarly, what is the domain of F inverse F is actually the domain of F. So take note, no matter what, is this actually needn't matter. If they ask you to sketch the graph of F inverse F or FF inverse, you always get y equals x. The only thing you need to take note is this, that the domains are different. These two graphs, the domains are different. I will leave you to read example 16 on your own, and then you can conclude this chapter. Thank you.